Hi everyone, I welcome you all for today's topic, numericals on short circuit capacity. First problem, an isolated synchronous generator with a transient reactance of 0.1 per unit on a 100 MVA base is connected to the high voltage bus through a step-up transformer of reactance 0.1 per unit on a 100 MVA base. The fault level at the bus is. So we have to find out the fault level at the bus. Let us see how to calculate this. They have given synchronous generator transient reactance value. So the transient reactance value is equal to 0.1 per unit on a 100 MVA base, and it is connected to a high voltage bus. So high voltage bus through a step-up transformer of 0.1 per unit. The transformer reactance is given 0.1, that is also on a 100 MVA base. So what is the fault level? So the fault level is nothing but short circuit MVA. So what is the MVA rating? The short circuit MVA. What is the formula for this? That is, we know MVA base by X per unit reactance, because they have given only the reactance value. If it is in terms of the impedance, this X will be replaced by Z. So now let us draw the single line diagram for this. They have given the generator which is connected to the high voltage bus through step-up transformer. So it is connected through the step-up transformer to a high voltage bus. So the transient reactance, the generator transient reactance is given as J0.1 per unit. The transformer reactance is given as this also J0.1 per unit. So they are asking us to find out the fault level at this bus. So we have to assume the fault has occurred at this bus. So now let us draw the circuit. So the generator will be represented as reactance, which is connected in series with the generator. That is source PG dash and XG dash is given as J0.1 per unit. The transformer also represented, it is a per unit reactance diagram, so which is represented in terms of the J0.1 per unit. So this is the bus voltage. So the fault has occurred here. So these terminals will be open circuited. So the X per unit. So X per unit is nothing but if you calculate by using the Thevenin's theorem, it is nothing but the X Thevenin. So how to find out with respect to these fault terminals, you need to find out the Thevenin's impedance, that is the reactance. So this circuit can be redrawn as, so if you deactivate the sources, the voltage source will be replaced by short circuit. So the rest of the reactance values J0.1, J0.1. This is the open circuit. From here you will find out the X Thevenin value. So the X Thevenin is equal to J0.1 plus J0.1, that is equal to J.2. So therefore, MVA short circuit is equal to base MVA. So they have given the base value as 100 MVA. So that value is 100 divided by 0.2. That is equal to 500 MVA. This is the short circuit MVA. Second problem. The estimated short circuit MVA at bus bars of the generating station is 1500 MVA and the another station is 1000 MVA. The generated voltage of each station is 13.2 kV. Calculate the possible short circuit MVA at each station when they are linked by an interconnected cable having the reactance of 0.5. So, before going to this, let us draw the circuit diagram. So, there are two generating stations. So, generating station 1 and generating station 2. Generator 1 and generating station 2. So, which are connected through a cable which is having a reactance of J0.5. Having a reactance of J0.5. So, let us draw the circuit for this. So, we will have first generator. So, EG1 and this is the XG1 value and the cable is having reactance of J0.5. So this is given in terms of ohms, J0.5 ohms, and here it is EG2, XG2. So, to find out the possible short circuit MVA at each station, so there are two conditions here. So, possible short circuit MVA at each station means, so we have two cases here, each station. So, case 1 is fault at, this is bus 1. So, this is bus 1 and bus 2. Bus 1 and bus 2. First case is fault at bus 1. Fault at bus 1. So, what is the MVA short circuit? Second case is fault at bus 2. What is the short circuit MVA? So, these two things we need to find out. Case 2 is bus 2. So, what is the MVA short circuit with respect to that? So, before finding that value, we don't know the value of XG1 and we don't know the value of XG2 and we need to convert this ohms into the per unit value. So, this much we have to do. So, how to convert? This also should be in per unit value. This also should be in per unit value. So, for that we will see what is the given data. In the given data, they have given estimated short circuit MVA. They have given MVA short circuit rating of generator 1. And this is the MVA short circuit rating of generator 2. And also they have given the voltage. This is the base voltage. We can take it as a base voltage as a 13.2 kV. Now let us find first these values XG1, XG2. Then we will see with respect to which terminals we need to find out the X Thevenin to calculate the short circuit MVA. Solution. Cute. They have given MVA short circuit value as 1500 for generator 1 and MVA short circuit for generator 2 as 1000. So we know the formula for MVA short circuit is equal to MVA base by X per unit. So we know the MVA short circuit of two generators, generator 1 and generator 2. If you know the MVA base value, then you can find out the X per unit for generator 1 and generator 2. But if you look at the problem, they haven't given the MVA base value. You can choose approximately the base value as 600 MVA. So anything you can change which is less than this 1000 and the 1500 MVA. So because the MVA rating of the system will be obviously less than the short circuit MVA. So we have taken close by the mid value of the average of those two values, that is 600 MVA. Xg1 value is equal to MVA base by MVA short circuit value of generator 1, that is equal to 600 by the first generator is given as 1500, which is equal to 0.4 per unit. Similarly, you can calculate Xg1 is equal to MVA base by MVA short circuit of generator 2, that is equal to 600 by 1000, which is equal to 0.6 per unit. Then what about the cable? So cable reactance is given as J0.5 ohms. I want to convert this into per unit. So what is the formula for that? X per unit, X in terms of ohms, X per unit equal to X in terms of ohm into MVA base by kV base. So voltage is given as a 13.2 square. This value will be approximately equal to 1.7217 per unit. So we got the values. So now you can represent the circuit diagram. So that is case 1. Case 1. We need to find out MVA short circuit at each station. First, I am assuming the fault has occurred at this point. So this is the fault point. With respect to these terminals, I need to find out the Thevenin's impedance. If I replace this circuit, so this is 0.4. The fault has occurred at this terminals. So now what I will do? Now, with respect to these terminals, I will find out my X Thevenin, or you can say that X per unit. X per unit. So, what will happen? If you look at 1.7217 and 0.6, so these two will be in series. So, this series combination will be parallel to this. Therefore, X Thevenin with respect to the station 1 is equal to, this can be written as X per unit, that is equal to J 0.4, which is parallel to J 1.7217 plus J 0.6. So if you solve, you will get J 0.3411 per unit. Therefore, short circuit MVA at station 1. Station 1, you can write it as a MVA short circuit is equal to base MVA. So that is MVA base by X per unit with respect to the station 1. So that is 600 divided by J 0.3411. That will give us 1759 MVA. And next, case 2. So at station 2, let us take the same circuit. So instead of at station 1, here the fault will occur at station 2. Now the fault has occurred at station 2. So now the Thevenin's impedance, how we will calculate? So deactivate the sources. So now the fault has occurred at the station 2 terminals. So that means with respect to these station 2 terminals, you will be finding the X Thevenin or the X per unit. So this is 0.6, this is 1.7217, and this is 0.4. X Thevenin is equal to 0.6, which is parallel to 1.7217 plus 0.4. So if we solve this, we will get J 0.4876 per unit. Therefore, short circuit MVA at station 2 is short circuit MVA at station 2 is base MVA 600 divided by, I want the magnitude I am finding. So this value actually it is 0.4876 at an angle 90 degrees. So this angle I am not considering, I am taking only this magnitude part. So this is magnitude of MVA base by magnitude of X per unit. That is nothing but 0.4876, which is equal to 1283 MVA. So this is how we have to do the calculations with respect to the short circuit capacity. I hope it's clear. Thank you.